Fixing an oversized electrical box hole in drywall can be achieved with several methods. Firstly, consider using spring clips designed specifically for old work boxes. Insert the spring clips into the hole and then push the box into place. The clips will expand and lock the box securely against the back of the drywall. Secondly, you can use corner brace brackets. Place L-shaped corner brace brackets inside the hole at two opposing corners of the electrical box. Screw the brackets to both the electrical box and the drywall. This provides extra support and helps align the box correctly. Thirdly, use drywall screws and washers. Drive drywall screws through the existing tabs of the electrical box and directly into the drywall. It's important to place large washers under the screw heads. The washers will spread the pressure and prevent the screw heads from pulling through the drywall. Fourthly, plastic anchors can be used. Drill small pilot holes next to the electrical box tabs. Insert plastic anchors into these holes. Then drive drywall screws without washers into the anchors. This helps to stabilize the box within the oversized hole. Fifthly, consider using foam insulating strips. Cut foam insulating strips to fit around the perimeter of the electrical box. Push these strips into the hole to fill the gaps. The foam provides friction that helps hold the box in place. Sixthly, you can use zip ties. Pass zip ties through the electrical box tabs. Loop them around nails or screws that you drive into the drywall nearby. Tighten the zip ties to securely hold the box in place. In addition to these primary methods, there are a few additional tips to keep in mind. Before applying any of these fixes, carefully trim any excess drywall around the hole. Use a drywall saw or a sharp utility knife for this purpose. Sand the edges of the drywall to smooth out any rough spots, ensuring a flush fit. Apply a small amount of construction adhesive around the box before securing it with any of the methods described. This provides extra adhesion. After the box is secured, fill any remaining gaps with drywall compound or caulk to create a seamless finish. These techniques offer various solutions for securing an old work electrical box when the drywall hole is too large. By combining these methods, you can achieve a stable and professional-looking installation without needing to replace the drywall. Remember to always turn off the power at the breaker before working with electrical components. When working with electrical boxes, it is crucial to ensure the box is properly grounded according to local electrical codes. Inspect the grounding wire within the electrical box and ensure it is securely connected to the box itself, if required, and to the grounding system of the house. If the grounding wire is damaged or missing, it should be replaced or repaired by a qualified electrician to maintain electrical safety. Before using any screws or fasteners, ensure they are of the appropriate type and length for drywall. Using screws that are too long can penetrate too deeply, potentially damaging wires or creating hazards. Shorter screws may not provide sufficient grip. Select screws designed for drywall use and choose a length that will securely fasten the box without protruding excessively. Furthermore, when using drywall compound to fill gaps, apply it in thin layers, allowing each layer to dry completely before adding the next. This prevents cracking and ensures a smooth, even finish. Overfilling the gaps in one application can lead to shrinkage and an uneven surface, which will require additional sanding and touch-ups. After applying the final coat of drywall compound and allowing it to dry, sand the area lightly with fine grit sandpaper to blend it seamlessly with the surrounding wall. Take care not to oversand, which can damage the paper facing of the drywall. A light touch will create a smooth transition and prepare the surface for painting or other finishing treatments. When tightening zip ties, avoid over-tightening them, as this can damage the electrical box or the drywall. Apply just enough pressure to secure the box firmly in place without causing distortion or stress to the surrounding materials. Over-tightening can also make it difficult to remove or adjust the zip ties later if necessary. In addition to foam insulating strips, consider using non-expanding foam sealant to fill larger gaps around the electrical box. Non-expanding foam provides a more substantial fill than foam strips and helps to insulate against drafts and noise. Be careful not to use expanding foam, as it can exert excessive pressure on the box and the surrounding drywall, potentially causing damage. Ensure the non-expanding foam is specifically designed for use around electrical components and is non-conductive. When using corner brace brackets, select brackets made of sturdy metal that are appropriately sized for the electrical box and the drywall thickness. Ensure the brackets have pre-drilled holes for easy attachment and are free from sharp edges that could damage wires or pose a safety hazard. Install the brackets securely, using screws that are long enough to penetrate the drywall and the electrical box frame without protruding excessively. If the electrical box is recessed too deeply into the wall, consider using electrical box extenders to bring the box flush with the drywall surface. Box extenders are plastic or metal frames that attach to the existing box and provide a level surface for mounting switches or outlets. Using extenders ensures that the electrical devices will sit properly against the wall, improving both safety and aesthetics. Always consult local electrical codes and regulations before performing any electrical work. Electrical codes vary by location and are designed to ensure the safety of electrical installations. Familiarize yourself with the specific requirements in your area and follow them carefully to avoid hazards and ensure compliance with the law. If you are unsure about any aspect of the electrical work, it is always best to consult a qualified electrician. A professional electrician can assess the situation, provide expert advice, and perform the work safely and correctly, giving you peace of mind. Remember that electrical work can be dangerous if not performed properly. Take all necessary precautions to protect yourself from electrical shock, including turning off the power, using insulated tools, and wearing appropriate safety gear. If you are not comfortable working with electricity, do not attempt to do it yourself. Hire a qualified electrician to handle the job. By following these additional tips and guidelines, you can effectively fix an oversized electrical box hole in drywall and ensure safe and professional-looking installation. Always prioritize safety and consult with a qualified electrician if you have any doubts or concerns about the electrical work. Keep in mind that even seemingly minor electrical repairs can have significant consequences if not done correctly. Taking the time to do the job right is always worth the effort. When dealing with old work boxes, it's important to inspect the box for any signs of damage or wear. If the box is cracked, warped, or otherwise compromised, it should be replaced rather than repaired. A damaged electrical box can pose a safety hazard and may not provide adequate support for the electrical devices. Replacing an old or damaged box is a relatively simple and inexpensive task that can greatly improve the safety and reliability of your electrical system. Before starting any electrical work, be sure to gather all the necessary tools and materials. This includes screwdrivers, wire strippers, pliers, a voltage tester, drywall screws, washers, plastic anchors, foam insulating strips, zip ties, and any other items specific to the repair you are undertaking. Having all the necessary tools and materials on hand will save time and frustration and help ensure a successful outcome. When working with wires, be sure to use proper wire connectors to make secure and reliable connections. Avoid using electrical tape alone to join wires, as this can loosen over time and create a fire hazard. Wire connectors, such as wire nuts or push-in connectors, provide a more secure and long-lasting connection. Always follow the manufacturer's instructions when using wire connectors. After completing the electrical work, thoroughly test the circuit to ensure that it is working properly. Use a voltage tester to verify that the power is off before touching any wires or components. Once the power is restored, test the switch or outlet to make sure it is functioning correctly. If you encounter any problems, such as a short circuit or a malfunctioning device, turn off the power immediately and investigate the cause. If you are unable to resolve the problem yourself, consult a qualified electrician. Remember to label all circuits clearly in your electrical panel. This will make it easier to identify and turn off the correct circuit in the future when performing maintenance or repairs. Use a label maker or a permanent marker to create clear and legible labels. Include information such as the location of the circuit and the devices it serves. Maintaining accurate and up-to-date circuit labels can save time and prevent confusion in the event of an electrical problem. When running new wires, be sure to follow all applicable electrical codes and regulations. Use the correct gauge of wire for the circuit and ensure that the wires are properly supported and protected. Avoid running wires through walls or ceilings without using conduit or other approved wiring methods. Improper wiring can create a fire hazard and may violate local electrical codes. When installing new electrical devices, such as switches or outlets, choose devices that are rated for the intended use. Use tamper-resistant outlets in areas where children are present and ground fault circuit interrupter or GFCI outlets in wet locations such as bathrooms and kitchens. Installing the appropriate devices can help prevent electrical shocks and protect against other hazards. Regularly inspect your electrical system for any signs of problems such as flickering lights, loose outlets, or warm circuit breakers. Address any issues promptly to prevent them from escalating into more serious problems. If you notice any unusual smells, sounds, or sensations, turn off the power immediately and consult a qualified electrician. Early detection and repair of electrical problems can save you time, money, and potentially prevent a fire. Consider installing surge protectors to protect your electronic devices from power surges. Surge protectors can help prevent damage to sensitive electronic equipment caused by lightning strikes, power outages, and other electrical disturbances. Use surge protectors on computers, televisions, and other valuable electronic devices. When using extension cords, choose cords that are rated for the intended use and avoid overloading them. Never run extension cords under rugs or carpets, as this can create a fire hazard. Inspect extension cords regularly for any signs of damage and replace them if necessary. Always unplug extension cords when they are not in use. If you are planning a major renovation or addition to your home, consult a qualified electrician to ensure that your electrical system is adequate for the increased load. An electrician can assess your current electrical system and recommend any necessary upgrades or modifications. Upgrading your electrical system can help ensure that it is safe, reliable, and capable of meeting your current and future electrical needs. Consider installing a whole house surge protector to protect your entire electrical system from power surges. Whole house surge protectors are installed at the electrical panel and can provide comprehensive protection against electrical surges caused by lightning strikes, power outages, and other disturbances. While individual surge protectors can protect specific devices, a whole house surge protector can protect all of the electrical equipment in your home. Regularly test your ground fault circuit interrupter or GFCI outlets to ensure that they are functioning properly. GFCI outlets are designed to protect against electrical shocks in wet locations such as bathrooms and kitchens. To test a GFCI outlet, press the test button on the outlet. The outlet should trip and the power should be interrupted. If the outlet does not trip, it may be defective and should be replaced. Use a qualified electrician to replace the defective GFCI outlet. When working with electrical panels, be sure to follow all safety precautions. Wear safety glasses and gloves and avoid touching any bare wires or components. Use insulated tools and work in a well-lit area. If you are not comfortable working with electrical panels, do not attempt to do it yourself. Hire a qualified electrician to handle the job.